This is section 9.5, Functions and Angles and Fundamental Identities. Okay, so to get started, we're actually getting into the trigonometry part of this course. We started with a review of some things having to do with angles and measures of angles and things like that, and that will develop us into this next idea. So let's assume that we have in the xy plane an angle in standard position. And when I say in standard position, again, that means that the initial side of the angle is on the positive x-axis, and the terminal side is just wherever it happens to be. So I'm going to make the terminal side, I guess, something like right there. I happen to pick a first quadrant terminal side. It doesn't mean it had to have been that. It could have been second, third, or fourth quadrant. I just decided to do this one, and that was a purposeful choice on my part. Okay, so the angle theta between those, going from the initial side to the terminal side, we'll call that angle theta. And what I want to do is I want to pick just some point on that ray. Doesn't really matter what point I pick. I'll pick that point right there and draw a line straight down to the x-axis. And when we do this, we'll always draw a line from the point on the ray to the x-axis, and the angle between that line segment I just drew and the x-axis is a right angle. Okay, that's on purpose. And the coordinates of that point, and I guess we'd call that point P, the coordinates of that point is just some xy pair. And of course, to get to that point, you start at the origin and move x units to the right, and so that's a distance of x to the right, and then we go up y, and so that's the value of y there. And what I want to introduce into this is as if there were a circle, and I guess I can try to draw the circle, though it probably won't look that good. I guess you'll just have to bear with me. Pretend like this is a really well-drawn circle centered at the origin. I want to make it kind of a light colored one so that it's not really a big part of what we're doing, but it gives you a little bit of context about what I'm about to say. If that is the circle, then from the center at the origin to that point P, the distance along that is the radius of the circle. So we're going to call this length R, just like it's the radius of a circle. Now there's a really important relationship amongst those three lengths between x, y, and r. There's a relationship. And because it's a right triangle, we know the Pythagorean Theorem applies, which means that x squared, leg squared, plus y squared, leg squared, equals the square of the hypotenuse, r squared. And if we wanted to solve for r, we could take the square root, which would give us the square root of x squared plus y squared. And someone may be thinking, can't I simplify that? And let me guess what you might be thinking. I'm going to make one up. What if this were 36 and 64? Would that be equal to, and it's probably what someone was thinking, would that be equal to the square root of 36 plus the square root of 64? In other words, you're trying to say over there to the left that that should simplify to be x plus y. I know that's what somebody was thinking. And when you have a thought like that, instead of just assuming it's true, what I'm going to do a lot of times is come over to the side and pick some numbers, and hopefully I'll pick nice numbers that I can deal with and see if it's true or not. And if I find that it, for my example numbers, is false, then that means you can't say it's always true. So if we do this problem the way it's supposed to be done, we'll do the addition first. 36 plus 64 is 100, and the square root of 100 is 10. That's what it's really equal to. The square root of 36 is 6. The square root of 64 is 8. 6 plus 8 is 14. That and 10 are not the same. So can the square root of x squared plus y squared be simplified to be x plus y? No. Okay, now you might notice that usually when I have something squared equals a number, when I solve for x, I always think to myself, well, I better insert a plus or minus so I get all answers in front of that radical. And isn't it true that 5 squared is 25? But isn't negative 5 times negative 5 also 25? So normally I put in that plus or minus. You notice over here I didn't, because r is the length of a radius. And so for this unit, the trigonometry unit, r will always be positive. Now in a later unit, and I'll go ahead and tell you the name of it, it's polar graphing and stuff like that, r can be negative. But so for right now in trigonometry, just keep in mind r is always positive, never negative, and that'll change later in the course. In a different world, a different setting, r can be negative, but not right now. R has to be positive here. Okay, so we're going to define trigonometric functions by relating the angle theta to the ratio of two sides of that right triangle. And so this is a definition, so there really doesn't have to be a reason why it's true, except for I'm telling you. No, actually there's a reason, but it's not the most important part of this right now. So the 6 trigonometric functions are sine, cosine, tangent, cosecant, and now I'm starting to talk about things you've probably never heard before. You may have heard of sine, cosine, and tangent before, but now it seems like I'm speaking a foreign language. There are 6 trigonometric functions, and the 3 you're not familiar with are cosecant, secant, and cotangent. And you might notice that I didn't write them this way, but you could pair these up into a function and its cofunction, like tangent and cotangent are cofunctions. Secant and cosecant are cofunctions. Sine and cosine are cofunctions. And these are always abbreviated with 3 letters. I wrote the entire word down there so you know what they are, but the abbreviation for sine is S-I-N. It is not sin. It is sine. If you're saying like sine of something, even if you're abbreviating it S-I-N, you still need to say sine. It's not sin. I'm sorry. People said that in the past and it just bothers me. Okay, so the sine of theta. And by the way, sine needs to be followed by something. It has to have an argument. It's like if I came in and said, okay, I'll give you 100 on the test if you can answer this question. What's the square root of? And you're waiting. It's like, the square root of what? Right. I haven't given you the argument of the square root function. I haven't told you all the information. That's the same thing here. If I say, what's the sine, that's not enough. I have to say, what's the sine of something? Just like I have to say the square root of something. So we're going to define sine of theta as y over r. Each one of these is going to be a ratio of two of those functions. Okay? So y over r is what sine of theta will be. Cosine of theta, which is abbreviated COS, not cos, it's cosine. So if you're going to say this, it's cosine of theta. That's defined as x over r. Tangent of theta is defined as y over x. And those are the three that you may have seen before. In fact, you've probably seen those three abbreviations on a calculator before. The other three are not buttons on a calculator, so that's probably why you haven't seen them as much, is because we just avoid them if we can. But anyway, the cosecant of theta, and cosecant is abbreviated CSC, the cosecant of theta is r over y. The secant of theta is r over x. And the cotangent of theta, and you see the abbreviations I'm using, is defined as x over y. And you need to add those 6 trigonometric functions and their definitions to your list of formulas to memorize. And we'll be using these pretty extensively in this course, so make sure that you get them memorized now so that when we use them later, you follow what we're talking about more easily. Now, I always write these 6 in the same order. It's kind of like when I learned a foreign language. I always, and when I was conjugating verbs, I always did first person singular, then second person singular, and then third person singular. And I'm hoping some of you are going, yeah, that's what my teacher did too. And so I'd say like, I am, you are, he, she, it is. Of course, that's English. And then next to that, I always put first person plural, we are, second person plural, so you all. Actually, Texans have a word that we use for that, y'all, is you plural. So anyway, you are. And then third person plural, the they form, they are. Okay? And I always write those 6 in the same order so that I know a pattern for that and I recognize it. And if I do it in that same order, I always get it right. If I mix it up, I might get it wrong, at least until I become very confident. So for that reason, I always list those 6 trig functions in the order I did, so as not to mix them up and mess things up. So it's kind of like learning the conjugation of verbs in a foreign language. If you always do it in that order, you're less likely to make mistakes. Okay. So there are a couple of caveats that I need to mention. Of course, for cosecant, for example, we can't divide by 0, so y can't be 0. For secant of theta, we can't divide by 0, so x can't be 0. And so for every one of those, there's a little caveat that we can't divide by 0. Now, one thing that we are not going to allow, and if you look at how I defined it up above, it should make sense. What did I say about r? Look up there. What did I say about r? Well, what I said was r is always positive. I didn't say greater than or equal to 0. I said positive, so r can't be 0. So you don't even have to worry about that. In this trigonometric world, r cannot be 0. So I don't have to write that caveat for sine and cosine of theta because r can't be 0. But for all the others, you have to remember you can't divide by 0. All right. So let's say that we have the terminal side of an angle. So let me draw a picture of it first. The terminal side of an angle passes through the point -3, -4. let's see. Let's say -3, -4 is right there. So that green line is the terminal side of our angle. And this is our angle from the initial side to the terminal side. And if that is what we have involved, let's draw that line segment from the point we put on the terminal side and draw a line segment to the x-axis. It's always to the x-axis, never to the y-axis. And this part of it is x, which of course is -3 for this problem because the point is at -3, -4, and y is -4. Notice I did not draw it to scale. I'm not too worried about that. It doesn't have to be drawn to scale. Now, the thing that we don't know yet is what r is, and this is why I had you learn that equation for r. Make sure you memorize it. I'm not sure I said that earlier, but you need to memorize this one. R is the square root of x squared plus y squared. I think I got caught up in talking about how that won't simplify. I forgot to say, yes, and please memorize that. Let me go back up there and box that because that's worthy of attention, that you need to memorize that, as well as the trigonometric functions. Those need to be memorized. So I won't always draw boxes around things. Just kind of pay attention when I say you need to know this or this needs to be memorized, that you put it in your list of things. Remember, you're keeping a separate list of all the things you're going to memorize in this course so that you can kind of keep track of them and start working hard on learning them. Okay, so for this particular problem, this will be the square root of x is -3 squared plus y is -4 squared. That ends up giving us 5, and so r is 5. And the question is, find the values of the 6 trigonometric functions of theta. Well, now we know what x, y, and r equal. All we have to do is use the formulas that hopefully you'll be committing to memory very soon. The sine of theta, that angle, will be y over r, so -4 over 5. And if that reduces, please reduce it. Cosine of theta is x, which is -3, over r, which is 5. I'd like for you to pause the recording and see if you can get the other 4 correct without my help. Okay, tangent of theta is y, -4 over x, which is -3, and that does simplify to be positive 4/3. Cosecant of theta is r over y, and 5 divided by -4 is -5/4. Secant of theta is r, which is 5 over x, which is -3. That simplifies to be -5/3. And cotangent of theta is x, -3 over y, -4. So that's 3/4. Okay, so that is our first round of finding all 6 trigonometric function values for a given theta. So now when we do this, it would not have mattered what point I picked on that ray. -3, -4 just happened to be the one that they gave us. But if I continued along that ray, there's another point that's a little bit further out. If I follow the slope of that line, I'm going run -3 and rise, if you will, -4. And so if I went to the next nice point on that, that would end up being the next nice point would be -6, -8. And so x would have been -6, y would have been -8, and r would have been the square root of -6 squared plus -8 squared, which would have been 10. And for example, sine of theta would have been y -8 over r 10, which reduces to -4/5, the exact same answer. So what I'm trying to say is it does not matter what point on that ray you use, you will still get the exact same sine, cosine, tangent, cosecant, secant, and cotangent of theta answers. So it doesn't matter what point you use, and you could do all 6 of them if you wanted to prove it to yourself. But I think that based on one example, you can say, oh yeah, they'd all reduce to the same thing. So here's another type of question you might see. Find the 6 trigonometric function values of the angle theta in standard position if the terminal side of theta had the equation x plus 2y equals 0, and with the caveat that we're only using x that's greater than or equal to 0. So I think it'd probably be a good idea to draw a graph of that line. So let me see, that mark is worth 1, and that mark is worth 1. Okay. Please notice that every time I draw axes, and I hope I did that up above, I'm always labeling the axes, x and y, is what we're using all the time here. Yep, I did. Oops, I forgot to put the y on this one. The reason I'm so consistent about that, and persistent, if you will, and insistent, is that later on we're going to be graphing in different planes that have different variables and different axes that mean different things. So I'm very insistent on labeling the axes because later on it will make a big difference. Is this in the XY plane? Is this in a different plane? That'll actually be an issue. Okay, so let's see. I want to graph that line. Well, let me first draw the initial side. Since I said it was in standard position, the initial side is here. It's the terminal side that we're graphing. Let's see, I know that 0 plus 2 times 0 is 0, so I know 0, 0 is a point. Let me see, what can I do to graph this? There are several options. You could solve for y and use slope-intercept form. You can just find the coordinates of another pair of points that will work. Like if I let y equal 2, that's not going to be what I want, because I want x to be positive. Okay, let's start with x. Let's let x be 2. When x is 2, 2 plus something is 0. Well, that something has to be -2. So y would be -1. So do you agree that 2 for x and -1 for y is a point on that? Sure. Or you could have used y equals mx plus b and solve for y. You have gotten -1/2 x for y, and that means the slope is -1/2, so go down 1 right too. Anyway, just saying. We need to find that line. And the angle goes from here all the way around to there. Okay? So, now we can't use 0, 0 on that line because that won't make sense. We'll end up not getting any information. So pick any point on that line. Well, being the lazy person I am, I already mentioned a point. Why don't I just use that one? 2, -1. Or if you found a different point with a different strategy, maybe you started with, I'm going to let x be 4. 4 plus something is 0. That something is negative 4. 2y equals negative 4 means y is negative 2. I could use the point 4, negative 2 instead. It doesn't really matter, as we saw above. So I'm going to use this one, and I'm going to first calculate r. It'll be the square root of x squared plus y squared, and that's the square root of 5. And of course, because I picked the point 2, negative 1, that implies that I'm letting x equal positive 2. I'm letting y equal negative 1. Oh, and by the way, that x greater than or equals 0, I'm only drawing from 0 to the right. The line, as it goes to the left, I'm into the second quadrant. I'm not using that part because they told me to make x greater than or equal to 0. So you do have to pay attention to the directions. That's very important. Okay, so we're supposed to find all 6 trigonometric functions. Once you've found x, y, and r, you're almost done. Now you just have to have memorized these 6 definitions. Sine of theta is y over r, and you cannot leave a radical in the denominator. So if you'll remember, I'm going to do this over to the side. You probably learned this in geometry, that to rationalize a number that looks like that, you multiply by 1 in the form of square root of 5 over square root of 5. Negative 1 times square root of 5 is negative square root of 5. Square root of 5 times square root of 5 is square root of 25. And that simplifies to be negative square root of 5 over 5. And after you've done that like 3 or 4 times, you're going to become an old pro, and you'll be able to write these simplified answers without having to go over to the side like I just did and do all that work. Practice it and you'll get better at it, and you'll be able to go straight to this really quickly. Okay, cosine of theta is x over r. And then rationalizing that, I get 2 square roots of 5 over 5. Okay, try the other 4 and see if you can do it. Put me on pause. Try these and see if you can get the other 4 answers. Okay, hopefully you were successful. Tangent of theta is y over x. Negative 1/2 is that answer. Cosecant of theta is r over y. That simplifies to be negative square root of 5. Secant of theta is r over x. Square root of 5 over 2 is simplified. And cotangent of theta is x over y, which simplifies to be negative 2. All right. Now, you may remember a vocabulary item I talked about in the last section was quadrantal angles. Those are angles whose terminal side ends on an axis. So we're going to start with 90 degrees. So x and y and initial side here, because it's in standard position. Terminal side, we're going to go 90 degrees, which puts us right there. And that's our angle. Now, what I'm going to do is I'm going to pick any point, except for the origin, that's on this green ray. And it doesn't matter what point you pick. What if we picked this point right here, and the coordinates of that point, let's let that be 0 something. Why not 1? It doesn't matter what we use, right? Well, if that's the case, what's r? Well, be the square root of x, which is 0 squared, plus y squared, 1 squared, and that's 1. So, oh, and by extension from the point I presented that means x is 0 and y is 1. I should probably write that down so that it's very clear where I'm getting those numbers from. It's from the point. So sine of theta is y over r, so that's 1. Cosine of theta is x over r. 0 divided by 1 is 0. Tangent of theta is y divided by x. 1 divided by 0 is not defined. It's an undefined number. So write UND period for undefined. It's a nice abbreviation. Let me talk for a second about division with 0. Undefined is one of the possibilities, and I want to talk about several of them. So in this discussion, I'm going to the side to do this. It's just kind of a by the way thing. We're going to let a be a non-zero number. Okay. So what if I have 0 divided by a? Well, you should know that that's 0. And when I'm doing division, go over here to the far right. When I'm doing division and getting an answer, like 15 divided by 3 equals 5, doesn't that imply then that 3 times 5, the number I'm dividing by, times my answer, is how I get the numerator? Isn't that true? So this answer implies that a times 0 is 0, which is true. Any non-zero number times 0 is 0. So that means that this 0 answer is correct. That's the only number that you could multiply by a that's not 0 to get the answer of 0. Okay? All right. Now, what if we have a divided by 0? And I don't know yet what to call that answer, so I'm going to call it b temporarily, and we're going to figure out what b is. Well, according to our definition of division over there, that means that 0 times b should equal a. Now, what number exists that you could call b, that when you multiply b times 0, you'll get a, which is definitely not 0? That's impossible. B is not defined. It's undefined. There is no such number that if you multiply this number by 0, you'll get something that's not 0. And that's why we call it undefined. Okay, then the last possibility when we're dividing with 0 is what if you had 0 divided by 0? Well, if you follow the top rule, because 0 is in the numerator, you think the answer's got to be 0. But if you use the bottom rule where you're dividing by 0, you may be thinking, well, that's undefined. Well, actually, it's neither one of those. Well, at least not necessarily one of those. Let's say that we are going to call the answer to this b. And that division problem implies that the denominator 0 times b will equal 0. Can you think of a number that you could put into that equation for b that would make it true? Any real number would work, including 0, including 5, including 33, including negative square root of 2. There are infinitely many answers, and so you can't determine without more information which number it is I'm looking for. So when you see 0 over 0, we call that an indeterminate form, because you can't determine the answer without more information. And so those are the 3 possible ways that you'll deal with division involving 0. 0 divided by not 0 is 0. Not 0 divided by 0 is undefined, and 0 divided by 0 is I don't know what, without more information. Okay, sorry, I tend to go off on tangents. Ha! You get it, tangents? Oh, never mind. quite often I tend to go off on things like that because I think they're important mathematical things to recognize. And when you see something like that, you'll now know how to address it. Okay, cosecant of theta is r over y, so that's 1. Secant of theta is r divided by x. So what is 1 divided by 0? Undefined. Cotangent of theta is x over y, which is 0. Now, just for grins, I want you to think about, well, what if instead of 0, 1, I picked 0, 4? Well, r would have been 4. If you do the calculation, you get 4. And like for sine of theta, you would have gotten 4 divided by 4, which is still 1. So the answers won't change. I happened to pick 0, 1, and I was lucky that that was actually the easiest to simplify. But had I chosen 0, 4, 4 over 4 being 1 would have been fine. 0 over 4 would have been fine. I mean, there are lots of these answers that I could have done very quickly and gotten the exact same answer with a different initial point. So these are the answers you'll get. And by the way, for quadrantals, this is kind of good information. There are only a few answers that are possible for quadrantals. And in fact, they're always going to have 2 of each type. You'll have 2 answers that are 0. You'll have 2 answers that are undefined. And then for the other pair of answers, they'll either both be positive 1 or they'll both be negative 1. Okay, so let's do the other quadrantals while we're thinking about it, because they're not that hard to imagine. And I'll be able to speed this up because a lot of the calculations are very similar to the ones I just did. So let's do the one that ends on the negative x-axis. In other words, 180 degrees. So I'm going to pick some point on here, and as it turns out, a very nice point for that is the point negative 1, 0. So that means x is negative 1 and y is 0. And if you calculate r, you'll get positive 1. So please verify that using the formula for calculating r. Like I said, I'm going to go through this kind of fast because it's all very similar. Okay, sine of theta is y over r, 0. No big surprise there. I told you get 2 answers of 0 every time. Cosine of theta will be x over r. Negative 1, also no surprise. That means not only is there a negative 1, there's another negative 1. So they're both going to be positive 1 or both negative 1 in this when you get all 6. Okay, tangent of theta is y over x, which is 0. So now I have my 2 answers that are 0, all done. Okay, cosecant of theta is r over y, which is undefined. There's one of my undefined answers. Secant of theta is r over x, negative 1. There's my other negative 1. And then cotangent of theta is x over y, which is undefined. So notice again, I have 2 answers that are 0, 2 answers that are undefined, and 2 answers that are either 1 or negative 1. For quadrantal angles, that's what you'll expect to see. Okay, let's do the negative y-axis one. And I want you to think about it and get the angle that is. What angle is that? It's 270 degrees. And I'm going to use a point here. 0, negative 1 is a good one. So that means that x is 0. y is -1. And if you do the calculation, r will be 1. So sine. Oh, I went and wrote theta each time up here, and I didn't mean to. Darn it, I'm going to have to go back and do a lot of erasing. It's not totally bad to write that because we've kind of defined what theta is, but I wanted it to be more clearly the angle that we were talking about. So I'm sorry, I'm going to go back and do a lot of erasing here, because these are special angles we're finding answers for. And I don't want to write generic theta. I want to write the actual angle behind it each time on these. So I apologize. So you get to go back and do a lot of erasing and rewriting. It's not that what I wrote was wrong, it's just not as informative as I wanted it to be. I wanted it to have the actual angle behind and not the generic theta. Okay, so what we were doing here was let me fix this so that's going to work. So this was sine of 90 degrees is 1. Cosine of 90 degrees is 0. Tangent of 90 degrees is undefined, etc. So these are all the trig function values of 90 degrees. And then down here, this was 180 degrees. Didn't leave myself a whole lot of room, so I had to squeeze in the 180 degrees. Make sure you're not writing 180, stop. It's got to be 180 degrees each time. Had I been doing it, it wouldn't have been that squeezed looking, so I apologize. So back to this one. This one will look better. Sine of 270 degrees is what I'm wanting to find. Okay, so let's see. Sine is y over r, so that's -1. Cosine of 270 degrees is x over r, so that's 0. Tangent of 270 degrees is y over x, so undefined. Cosecant of 270 degrees is r over y, so -1. Secant of 270 degrees is r over x, so undefined. And cotangent of 270 degrees is x, 0 over y, -1, which is 0. So, was I right when I said you'll always have two answers in this for quadrantal angles? 2 of them will be 0, 2 of them will be undefined, and the other 2 will be either both +1 or both -1. So far, my statement is truthful. Okay, so last one. And we can think of this as ending on the x-axis. We can think of that as 0 degrees or 360 degrees. They are coterminal, so it doesn't matter which one we want to think about. Drawing the 360 makes me see an angle. Otherwise, I wouldn't be drawing any kind of arc. So I'm going to call it 360 degrees. But the answers, if this were 0 degrees instead, would be exactly the same. So I need a point on that terminal side. I like 1, 0, which means that x is 1, y is 0, and you could calculate you could calculate r, and it would be 1. So sine of 360 degrees, which is the same as sine of 0 degrees, would be y over r, 0. Cosine of 360 degrees is x over r, so 1. the tangent of 360 degrees is y over x, which is 0. The cosecant of 360 degrees is r over y, so undefined. The secant of 360 degrees is r over x, so 1. And the cotangent of 360 degrees is x over y, so undefined. All right, there we have it. Those are all the quadrantals, and of course if you have a coterminal angle, like 0 degrees, could be substituted in for every 360 degrees there, and the answers would stay the same. 0, 1, 0, undefined, 1, undefined. Kind of reading top down and then right side top down. Okay, so those are all the quadrantal answers, and those are ones that you should be able to get without any problems. So if you turn a couple of pages, they have sort of a table where they've kind of combined all of the quadrantal angles into one table with all the answers. And I suppose you could think, gosh, I need to memorize this. I wouldn't. I would do exactly what I did here. Find a point on the terminal side. It'll be something that involves 0, and I would use 1 or -1 when I could, because the simplification will be as easy as it could possibly get. And just figure them out like we did here, because you're going to have memorized the definitions anyway. Sine of theta is y over r, for example. You're going to have all those memorized no matter what. So this is the way I would do them. I would not look at that table and go, boy, I better memorize that. What a waste of time that would be. Just figure them out as needed. Now, one thing that I've been skirting, and maybe you've been chomping at the bit for me to say this because you realized it way faster than I acknowledged it. But did you notice that I, on purpose, wrote sine of theta, and next to it I always put cosecant theta? And why do you think that is? What's the relationship between those two? They're reciprocals, right? They're reciprocals of each other. Y over r, if you do its reciprocal, is r over y. Well, what about cosine of theta and secant of theta? Was that happenstance? Did I just happen to do that accidentally? No, that was actually very purposeful. They're reciprocals of each other. How about tangent and cotangent? Well, yeah, they're reciprocals of each other too. So that's on purpose. I'm writing the reciprocal relationships that are less common on the right across from their reciprocal functions always, and that way I'm less likely to make mistakes. So this leads us to our first identities, called the reciprocal identities. I should probably talk about what an identity is before we get into this. So let me go off to the right and kind of talk about that. If I have an equation like 2x plus 3 equals 7, then there's only a finite number of answers that will work there, right? In fact, there's only one answer. It's 2. Okay? Or if I wrote an equation like, I'm going to make this easy, x squared equals 49. There's a finite number of answers. X is either 7 or -7, right? So there's only some numbers that work. Like if I were to put into the first equation, put 10 in for x, that's going to give me a false statement. 2 times 10, 20, plus 3 is 23. 23 equals 7 is a false statement. The only true statement is for a very limited number of values, in this case a single value, x equals 2. An identity, on the other hand, is something like this, that no matter what number I put in for x, the left side and the right side give me the same answer. In this case, all real numbers make this true. Pick any real number you want. Substitute it into the left side, substitute it into the right side, and the two sides will be the same. Of course, we know this is the distributive property, so obviously it has to be true, or we've been lying to ourselves all this time about the distributive property. But this is what we call an identity, when it works for every real number in the domain. And I'm going to say that because there are certain times we're getting undefined answers with these trig functions. So we have to be careful. So I'm going to say in the domain of the functions involved, or the variables involved. So we have to be careful about undefined results, because then it's not an identity for those. So we throw those out where it's undefined, and for any other real number except for those, if it makes the left side equal the right side, then it's what we call an identity. And here's our first one. Sine of theta is the same thing as 1 divided by cosecant theta, because they're reciprocals. That's the reciprocal relationship. Okay? Cosine of theta, its reciprocal is secant of theta. So as long as we are putting in numbers for theta that won't give us an undefined answer, then the sine of theta and 1 divided by the cosecant of theta for the same theta will give us the same answer on both sides. And so this is just an acknowledgement of the reciprocal relationship we saw earlier. And so the reciprocal of cosecant is sine. And by the way, the reciprocal identities that I'm writing right now, cosecant, secant, and tangent, cotangent, those are not buttons on the calculator because of these identities. Let me finish writing them all down and I'll give you an example. For example, if someone said, hey, I'd really like for you to pick up your calculator and calculate the cosecant of 12 degrees. Well, there's no cosecant button, so you're going to feel like, oh my gosh, I'm out of luck. No, because of the reciprocal identity, you can say, well, I know that's equal to 1 over the sine of that same angle, 12 degrees. And that's something you could type into your calculator. Now, before you get into typing, remember we have angle measures in now 2 different units of measure. So you're going to have to check your calculator to make sure you're in degree mode, because we're going to type in the 12 degree as an angle. If I'd said cosecant of pi over 7, you'd want to be in radian mode. And you need to know how to switch from one to the other, because in this section, in this chapter where we're possibly calculating values using our calculators, you're going to have to know how to switch between radian and degree mode. So if in class you haven't figured out by then, talk to me in class and we'll figure it out. If for no other resource, what you can do is you can Google the name of your calculator, and then once you're in there, you can look at the user guide, and or maybe even in your Google search put what you're trying to do, like switch to radian mode, or calculate using degrees, or something like that, and it should give you some indication of how to change it. But if not, we can talk about it in class. So what you type to get the cosecant of 12 degrees would be 1 divided by sine of 12, and then of course you'd have to be in degree mode to get the right answer. So you have to check that out first before you type anything. So I'm going to type 1 divided by sine of 12. I'm in degree mode. And what I got was this approximate answer, 4.810. So if you're not getting that, we need to talk about it in class to make sure you can get that exact, or get that answer without error. Okay, anyway, without those cosecant, secant, cotangent buttons, the only way to get cosecant, secant, and cotangent answers is to know identities. And so this set of 3 identities on the right, those are extremely useful, as you can see. Okay, so what types of questions might we encounter? Well, they're asking us in part A here to find cosine theta given that secant of theta is 5/3. Well, using the second identity I wrote, cosine of theta, which is what we're looking for, is 1 over secant theta. That's the identity. And then substitute into that identity with the value that we were given for secant of theta, and then do the arithmetic. To divide fractions, you take the numerator and multiply it by the reciprocal of the denominator, and you get 3/5. Okay, so that wasn't that bad. Not too hard. B. Find sine of theta given that cosecant of theta is negative square root of 12 over 2. Please pause the recording, and I want you to try this on your own, see what you get. Make sure you simplify your answer completely. And I'll come back in a minute and we'll talk about the answer. All right, so let's see how you did. Sine of theta, according to the reciprocal identity, is 1 divided by cosecant of theta. So that's 1 divided by cosecant of theta. Oh, but wait, is square root of 12 simplified? I don't think it is. Before I do the division, I want to simplify that sum. The square root of 12 is 2 square roots of 3, which will be divided by 2. So that'll simplify to be 1 over negative square root of 3. So I guess if I'd been smart, I would have seen that sooner and simplified this before getting into the identity, so I wouldn't have had such a messy looking first couple of steps. Oh well, hindsight's 20/20. Anyway, this is negative square root of 3 over 3 is what you should have simplified that to be. And I hope you caught the square root of 12 as 2 square roots of 3 early rather than late, because otherwise you were rationalizing square root of 12. Oh, wow. And then simplifying. I'm sorry. You had a lot harder problem than if you recognized that simplifies first. Okay. I think I'm going to close this one off and start another video because I'm out of room on the bottom of this, so I will see you in the next video.